Hey guys, Miss Sam's here. So I'm going to be going over graphing linear equations today. So I'm going to be writing on the second monitor. So in the video, if you see my head turn, it's because I'm looking at the monitor that I'm going to be writing on to doing the screen share. So just kind of bear with me if my head's turned to the side. I'm not ignoring y'all. I'm just looking at what I'm writing on the screen. So today is Monday, and we're going to go through the Zoom activity slides that we did in our live interactive Zoom today from 9 to 10. It was new content, so I wanted to make sure that I addressed it on Zoom Live. And then I'm going to go through exactly what we went over on Zoom with you all now to be watching the replay. So we are going to be graphing inequalities, which, as we know, inequalities do not just have a single solution. They have multiple solutions or multiple X and Y values that can make the statement of the inequality true or false. So first, we're going to go with graphing like we have been, graphing with what we are familiar with, and that is y equals mx plus b. So please do not allow this particular inequality sign to freak you out or anything. Let's just pretend like it's not even there for the moment, and let's just treat it like a straight equal sign like we are used to. So I'm going to start with, we'll just keep it with blue, why not? I'm going to start with the y-intercept here, being positive 3. And again, make sure that you're using the y-axis to graph your y-intercept. And then I'm going to be using the slope 4 over 1. So from here, I'm going to go up 1, 2, 3, 4 over 1. As you can see, it kind of runs off this graph. So don't forget that you can go in the opposite direction. So if we fall 1, 2, 3, 4, I'm going to run to the left. And it's still going to create a positive slope at the end. Okay, so I graphed my particular equation on the coordinate plane. Now it's time to take into play that inequality sign, okay? So my inequality sign was greater than, and it did not say equal to. So again, my inequality sign was greater than, and it did not say or equal to, like that line for or equal to is not underneath that. So that means that my particular line must be dashed because it is not equal to. So I'm going to create a dashed line, okay, as I'm graphing it. And then the next step is it is an inequality. So we're used to every single point on this line being a solution to the particular equation. For example, if I was to plug in negative 1, it would be true. So let me just show you. So negative 1 is equal to negative 4 times negative 1 plus 3. So is negative 1 equal to negative 4 plus 3? Negative 1 is, in fact, equal to negative 1. So see how that is a true, like it equals each other. Okay, the next part is my particular inequality does not have an equal sign. It has the greater than sign. Sorry, I had to look to see which one it was. Is greater than. So that means we can have multiple X and Y values that can make that statement true. So the most common point to choose is going to be 0, 0. Okay, I have to pick a point that is not graphed on the line. And what that means is the points that are on the line are the blue ones. Well, in this case, they're blue. So negative 2, negative 5 was a point that was graphed on the line. Negative 1, 0, 2, and then 1, 7 if I was to graph that point as well. So I'm going to use the point 0, 0 to see if it creates this particular inequality if it creates a true statement. Okay, so again, I'm going to use the point 0, 0. So I'm going to take 0 for my y value. Is 0 greater than 4 times 0 being the x value plus 3? Okay, so is 0 greater than 0 plus 3? Is 0 greater than 3? No, that is a false statement. 0 is not greater than 3. So that means that my solution does not include 0, 0, or really any points that are below this line, because 0, 0 is below the line. That also means that any particular point that is above the line here is going to make that particular inequality a true statement. Okay, so one of those particular points is negative 1, positive 1. So let's just try it to see if it works. So I'm going to use negative 1, positive 1. So we have 1 for my y value is 1 greater than 4 times negative 1 plus 3. So 1 is greater than negative 4 plus 3. 1 is greater than negative 1. That is a true statement. Okay, another particular point over here, if I was to use, let's just use negative 4 and negative 4. So 4 was the y value. Is 4 greater than 4 times negative 4 plus 3? Is 4 greater than negative 16 plus 3? Is 4 greater than negative 13? Yes, it is. So any point on above that line happens to make that particular inequality a true statement, which is why we are shading in everything that is above the line. We did not shade anything below it because 0, 0 was not a solution. Okay, so I know that was a lot. Okay, so we are going to, there we go, clear the whole thing. Okay, so we're going to go on to another example just so we can make sure that we're clearly understanding this before I release you guys to do it on your own. Okay, so the next one, first thing I see is I see that there is a or equal to, so that line is there. So that means that my line that I'm graphing can be solid. I don't have to worry about it being dashed. I'm going to start with my y-intercept being 5. And then I'm going to use the slope, which is rise over run. Don't forget that piece. Negative 4 over 1. So 1, 2, starting from here, fall down 1, 2, 3, 4, run 1. 1, 2, 3, 4, run 1. Okay, remember it said or equals to, so my line is able to be solid. I'm just going to undo that because that was a mess. Oh no. Okay. There we go. Let's try that again. Okay, it's a little bit better. Okay, so now we need to figure out, am I shading below or am I shading above that line? So again, the simplest point to use, as long as it's not graphed on that line, is going to be the point 0, 0. Okay, it's not graphed on that line because here's the point 0, 0, and my line is hanging out over here. So let's try it. So I'm going to use the point 0, 0, x, and then the y, right? Okay, so is 0 less than negative 4 times 0 plus 5? Okay, is 0 less than negative 4 times 0 is 0, and then we add the 5 to it. So is 0 less than 5? Yes, that is a true statement. So everything on the 0, 0 side gets included in the solution because it makes a true statement. Okay, now you can test it. You can prove me right. You can prove me wrong. But if you was to pick any particular point in this purple section that I shaded, or any point really below this red line, your statement is going to be true, which is why we're shading it, because that's a lot of points just to put on the graph. So just scribble and shade that in. Okay, let's do a couple more. Clear all of this off. Okay, so let's do this one, 1/3 x plus 3. So something that I notice is I have the or equals to, so my line can be solid. Remember, if it's a not or equals to, meaning it's just less than or greater than, my line has to be dashed. Okay, so I'm able to choose a solid line here. I'm going to go up 1 over 3, 1, 2, 3, up 1 over 1, 2, 3. You can also go in the opposite direction, down 1 over 1, 2, 3, as long as you are keeping your slope positive. Okay, connect those with a line. And remember, it could be a solid line because it said or equals to. Next, we need to test to see, am I shading below or am I shading above? So 0, 0, we are in luck, is not on the red line. So I'm going to use 0, 0 as my tester point. So 0, again, we have an x and a y. 0 is going to go in for my y value. So is 0 less than or equal to 1/3 times 0 plus 3? And again, it's always a nice one to use whenever you multiply it by 0 because this answer is 0. So is 0 less than or equal to 3? It is. So this is a true statement, which means that I'm going to shade in everything below the line because 0, 0 was below the line. So all of this section down here is a solution, or it makes the statement true. So I'm going to shade in all of that. Okay, hopefully I haven't lost you yet. I do have one more example to go over because sometimes 0, 0 is not able to be used. And I know that because if I was to graph the equation of this line, my y-intercept is 0. So 0, 0 is going to be on this line. Something else I notice is my or equals 2 is there. So my line is going to be solid and not dashed. So from my y-intercept, I'm going to go up 1, 2, 3, 4, 5 over 1, 2, 3. Down 1, 2, 3, 4, 5 over 1, 2, 3. Okay, again, my line is allowed to be solid. Okay, that line wasn't too terrible. And I can no longer pick the point 0, 0 for this one because it is lying on that graph that I put on the coordinate plane. So let's just choose another one. So another one that I see that could include a 0 could be anything on the x-axis. So we have 5/3. Let's choose something that has a 3 on it so my fractions will come out nice. Okay, so let's use the point 3, 0. Okay, I'm going to put that up so I can use a different point. Okay, I'm going to use the point 3, 0. And in class today, we had various points being used. So again, it doesn't matter what point you use, just pick one, and then you're either going to shade below the line or above the line. So I'm going to use y value is 0, and then 3 is my x. So it's 0 less than or equal to 5/3 times 3 over 1 plus 0. So is 0 less than or equal to 5 times 3 is 15 divided by 3. So is 0 less than or equal to 5? Okay. Now the next point that I'm going to use, let's try -1, +1. Okay, so we're going to choose -1, +1. Okay, so this is my x, this is my y value. So is 1 less than or equal to 5 over 3 times -1? So is 1 less than or equal to -5/3? No, it is not. So this is not true. Y'all, I don't know what it's with me today. It is definitely a Monday. Y'all were probably screaming in my video, Miss Sam, 0 is less than 5. What are you doing? Yes, 0 is most definitely less than 5. So that was a true statement. Again, now my pen isn't working. We're just going to change this real quick to green. And yes, 5 is less than 0. So this is a true statement. So that means everything that includes, 3, 0 was below the line. So that means everything down here is a possible solution, and it makes the statement true. So everything below that line gets shaded. Okay, so I know this video is long, but before I go off of the video, I also wanted to tell you that you are going to be graphing them by hand in TeacherMade today. So I'm going to clear off all of this. So you're going to be graphing them by hand in TeacherMade, and then also we're going to be graphing them in Desmos.com, okay? So if you go up into your particular assignment for today, you are going to have, once it loads, you're going to have two parts of the assignment. So the first one is TeacherMade. That is going to take you to this particular document here. Again, once it loads, you're going to be graphing them by hand. Be very careful about the lines that do not have or equal to on them. You have 6 questions to graph by hand. And then we're going to be diving into Desmos.com. So I'm going to go into Desmos.com here. There we go. Okay, and the equation that we needed to graph that I just got done graphing with you was, sorry, I know I'm like flip-flopping around like crazy. Let's do this one. I didn't graph this one. So y is greater than or equal to -4/5 x plus 4. So go into Desmos. So if you go to the keyboard, just hanging out down there, we can do y. Here is your inequality sign. So let's do greater than or equal to. I think that's what it said. Yes, greater than or equal to -4 divided by 5. Click off of that. We're going to do an x. I'm just going to type x on the keyboard. And then I think I said plus 5. Nope, it said plus 4. I'm glad I looked. So we're going to add 4. And my particular inequality is graphed on Desmos.com. So you are able to export this here. We're going to export image. Sure, thin, medium, small, whatever. Download it. And then you are going to go to your particular Google document and you're going to click and drag where it says insert graph here. Now, I'm not going to, I'm going to go ahead and release it, but please note that this is not the answer to number 1. Okay, so then I'm going to delete this because again, that's not the answer to number 1, but we're going to click and drag and you have 6 particular inequalities to use with Desmos.com. And it's very important that you understand how to graph by hand and use Desmos.com because we don't know whether it's going to be, well, not that we don't know. I'm not the test creator and it has a possibility of showing up on calculator inactive or calculator active. So it's best that you know how to do both ways. Okay, so that is it for graphing linear inequalities. And then of course, with linear equations came systems of equations. So systems of equalities is coming your way this week, but we need to first make sure we can graph one line at a time and shade in its solution before we throw 2 in the coordinate plane. As always, I am a private comment on Google Classroom away, or always you can also shoot me an email. So best of luck to you. Reach out if you need me.